Very good evening, sir. Okay, so I guess everyone is joined now, so I hope we are to start with the class now. Okay, so first of all, wishing you a very good evening, everyone. Let's just continue with the class. So, as you know, in the previous class, we are just left with this question there. Okay, I guess we are discussing about the question, and the class was abruptly ended there. So, yes, what is the correct answer for this question? Okay, so this is the topic of discussion we are discussing in the previous class. So, in this case, if you're observing something that as we already covered, like you can apply the sort trick. This is the carbon you have to consider, and okay, here we are taking a two molecule of this. We are going to follow the aldol condensation part. So let's see how it is going to work simply. That it's a carbon double bond, oxygen, plus one more, that is this bond is there. So you have to consider this be like CO group. And with respect to this, okay, so this is the group here. Like both combine this and this group. And what we are getting basically that the OH group formation here and this carbon is combined with this. Okay, so like this. And then the CO bond is there. Okay, and then further hydrolysis we are going to follow that this and this going to release and we are getting a double bond like this. Okay, simply. So this is the correct answer. Let's just check what will be the correct answer for that question. That option C is the correct here. Okay, so in this case, maybe it's look like different from the given product there, but you can change. Okay, it's nothing. It's simply be like I can write this be like that way as well. Okay, so this is the final answer of the question. Okay, so like this was the last topic of the previous class. Okay, I hope it's clear for you. Now let's continue further. Okay, so let's start. So as we are discussing about the aldol condensation, so aldol condensation, simple condensation part we already covered. So let's just talk about the cross aldol condensation. So what is the meaning of the cross aldol condensation? That in this case we are using two different asymmetric kind of molecule there. Okay, let's see how. So in this case, again, let's just discuss that I'm using a kind of acetaldehyde. COH group is there, okay, and plus that it's a CH3 and a CO and a CH3 there. Okay, so in this case, basically, total four kind of product we are end up. Let's just suppose this is one and two. Okay, so the case number one, when one and one combine, so which kind of product we are getting? It's a CH3 and a carbon double bond CO and a CH is there. This is the product number one we are getting that when one and one combine. The second product that when two and two combine. So what is the meaning? That in this case CH3 and a CO and carbon double bond carbon. So this is the carbon double bond and it is a CH3 and carbon CO and CH3. So this is the product number two, one carbon. Okay, done. What if let's suppose one combined with the two? Okay, so what is the product? That it's a CH3 carbon double bond CH and a CO and a CH3 there. This is the one and two combined, or maybe two and one combined. Okay, so what is the product? Which kind of product we are getting there? That is, it's simply CH3 C double bond Carbon double bond, don't worry, I will change the position of my video. And this is a carbon and it's a CH is there. So basically in this case, we are end up with four kind of product, okay? So let me just highlight the product. That is, this is a product number one, okay? This is a product number two, and this is a product number three, and this is a product number four. So this is a cross-aldol condensation. In this case, if you are observing, we're using two different kind of reactant there. That is a reactant number one is this, okay? And the reactant number two is this. So total two kind of reactant we are getting, that one is the blue one and one is the yellow one, and basically we are end with four kind of product. And you know very well, when we are having more than one kind of product, so we have to go with the major product. But now the question be like, let's just use some number or the alphabet. It's a B, C, O, D. Like which of the following is the major product here? Okay, so this is the important part. Like A is major, B is major, C is major, or D is major. Okay, so let's try to understand which of the following is the major product here. Okay, so I hope it's visible now. So let's see how to identify. Now we are going to discuss about like on which factor the cross aldol condensation or aldol condensation is really going to depend. Okay, so let's discuss about the stability of the enolate ion. Okay, so let's discuss about the condition, like how to identify which one is the major product. Like A is major, B is major, C is major, or D is the major one. So what about the factors? So in this case, that factor affecting the stability, if we are checking about the factor affecting the stability of the product, stability of the product. So let's discuss about that. What is the meaning of the factor affecting the stability of a product? So in this case, the point number one is going to be the stability of enolate. Okay. So what is the meaning of the stability of a enolate? Okay. So let me tell you actually what is going to happen. For example, let's suppose, okay, what is enolate? That this is a CH3 and this is O double bond, right? And this is a CH2 there. And this is a negative charge. In the previous class, we discussed about how to form the enolate, right? And in this case now, look at this negative charge may be transferred and this bond up and up, right? So this is a kind of simple that enolate kind of formation there, and like it's a kind of resonance kind of thing. Okay, so means basically what we are getting, we are getting CH and a O negative and a double bond CH2 there. Okay, so this is the thing basically we are getting. So directly indirectly, in this case, what is the key point? That is a double bond, right? And everyone we know about that if we are having a double bond, how a double bond is going to be stabilized just by more substituted thing. Okay, if this is a carbon double bond, and in this case I'm getting more substitution, so it will be the more stable. Yes, for example, let's suppose that in this case, if this is a carbon-carbon double bond, okay, let me give you some kind of, okay, let's just suppose it is connected with more 2CH3. So it's a more substituted double bond, right? The point is what? That is alpha hydrogen. Remember the hyperconjugation. So in this case, 3, and total 3, that is a 9 alpha hydrogen we are end up. And obviously it's going to be the stable one. Second type of enolate, that if you are having a carbon-carbon double bond and it is connected with only one CH3 group, okay, so it's a CH and a O negative there, simple. Okay, now the second point, that this is much more stable, and again you can check it for the alpha hydrogen, like the 3 there and 3 there total. So in this case you will be having total 6 alpha hydrogen, and this is much more stable over if this is a CH3 and a O negative double bond and normal CH2 there. In this case there is a 3 alpha hydrogen. So this is how you can decide the stability there. Okay, and even it's much more stable over if there's a 0 alpha hydrogen, means that O negative double bond and a CH2. And look at this. So it's a, you can say that 0 alpha hydrogen. So this is how you can decide the stability there. Okay, so like normally we are checking just actually, see, I have exam. Okay, so I'm going to take the class today, tomorrow, and after that I'm going to take the class only from Monday. Okay, and after Monday regular classes. That means no leave for Sunday or any. Okay, so if we are considering the syllabus, so probably yeah, of course, that 19 November. Okay, before 19 November, I can do. Okay, I guess your name is Abhishek. Okay, so that's it. So let's continue what we're discussing here. That we're discussing about the stability of a enolate ion. Okay, this is how you can decide. The point number one, the normal, the stability of the enolate ion. Now the factor number two. Okay, so how about the factor number two? That is the second factor, attack of the enolate ion. Right? There's a 2 point, that attack of the enolate ion. Enolate will occur. I will tell you how. Occur on more electron deficient, more deficient carbonyl carbon. Okay, so like this. So what is the meaning of this? Just let me know. Like actually what is happening in this reaction? One is being like a nucleophile, one is being like electrophile. Let me quickly give you a brief about the aldol condensation. For example, if let's suppose you are having this CO and this is a OH, first of all the base is going to abstract the hydrogen, right? So we are getting it's a two negative, like hydrogen, one negative charge generated and a OH simply. So what is it? Negative charge formation there. So OH is a base is going to abstract the hydrogen, and directly indirectly it's behaving like a nucleophile. The point number one, right? That we used to call this as a enolate formation. The second point, that in this case what is happening, there's a some one more CH and a CO. Let's suppose this is a ketone and a CH3 there. Okay, so basically due to the partial negative charge and a partial positive charge, it is being like electrophile. So directly and indirectly it's just a nucleophile attacking on a electrophile. This is how the reaction is going on. So what is the point written here? That attack of the enolate ion will occur on more electron deficient carbonyl compound. Okay, now just let me know between these two cases like aldehyde and ketone. First of all, I'm having aldehyde and one is the ketone there. So what is the basic criteria that you will be having a carbonyl compound at least with one alpha hydrogen, right? For the aldol condensation there. Now my question to you, between A and B, which one is being like a good electrophile? Yes, please. Anyone? Okay, not an issue will come. Yes, please. A or B, which one is a better electrophile? I'm asking about a electrophile, not a nucleophile, okay? Yes, please. Which one is a better electrophile? What do you think? Electrophile means electron deficient. So check it like aldehyde is deficient or the like ketone is deficient. Okay then, so let's discuss about this, that which one is a better electrophile here. So in this case, if you're observing, that is the CO is connected with two electron donating group. Okay, so one this side and a one this side. On the other hand, in this case, if you're observing, that is only one electron donating group is connected there, right? So in this case, that which one is a better electrophile simply, that obviously the aldehyde. Why? Because in this case, only one electron donating group connected. You know what is the meaning of deficiency? That nucleophile is waiting that should I to attack on B or A. So B will like I'm less electron sorry, I'm more electron deficient. Just give me some electron because the ketone already two CH3 group is connected. Okay, so be noted everyone, if you are having aldehyde and ketone both is there. Yes, very good, Arul. If aldehyde and ketone both is there, so every time aldehyde is a better electrophile. Be noted. This is really, really much important. Okay. So I hope the point number one is clear for you. Okay then. So it means like this is a wrong part. Okay. I can't take this as a aldehyde. I can take this as a nucleophile. Yes. So after deciding all the thing, let's just shuffle. Okay. It means one thing is sure, that if aldehyde is being like electrophile, so definitely I'm going to abstract the hydrogen from the ketone part here. So the step number one is going to be the CH3, okay, and then H positive abstract this, and then we are getting normally the CH3. Okay, this is how you to decide like which one is being like electrophile or a nucleophile in a reaction, and it's going to be the aldehyde. Okay, like this. This is going to attack, that nucleophile is going to attack here, and after once the nucleophile attack here, what we are end up that this bond open up, right? And this is a CH3 and this is a O negative. Okay, and this carbon connected with this basically the CH2. I will highlight like what is happening. Wait for a while. Okay, So this CH2, basically this CH2, okay? And okay, I hope this point is clear. Is it visible? Yeah, it's visible. Okay, so this is how we are getting, and then you know the next step is going to be the that is a protonation there. So what is happening after the protonation? Normally that OH ion formation. So this is OH and a hydrogen, and after once the hydrogen the alcohol formation is there, next step is going to be the hydrolysis step. Okay, so it's a CH2 and a CO and CH3. So it means after all the point of discussion, what is the final conclusion that out of all the four products, this is going to be the major one. Okay, so let's just back where we're discussing about four kind of product. So like out of A, B, C and D. Okay, I know here we are having a double bond. Like you can go, let's just back again. You can just simply observe that if you are removing this OH there, so basically you are end up with a double bond here, right? So let me just write a double bond. So this is the final product. So now between A, B, C and D, which one is the major product here, right? So let's just back here. So look at this, that how to decide which one is being like electrophile or which one is being like a nucleophile. So in this case, look at this. Aldehyde is a if carbon connected with a double bond, it means that point is going to be like electrophile. So here aldehyde is electrophile, or in this case, aldehyde is electrophile. Okay. In this case, if you are observing, in this case, if you are observing that it's a this kind of group, is it what? Ketone. Ketone is being like electrophile. No, we just discuss just by using this factor that is ketone. Ketone is not electrophile. So option these two is not the correct answer. So maybe option A can be the correct or maybe option B can be the correct. Right? So this is how you can decide A is correct or B is correct there. Now, in this case, look at this. That ketone, we're taking the ketone, right? So in this case, that this is aldehyde. So look at this. Now, that there is a tie that both are the aldehyde. Aldehyde is the electrophile there. So I have to raise the this point, okay? I have to just highlight the main thing. That is the stability of a double bond, right? After once checking the electrophile, now the second point, we are going to check it for the double bond, okay? So look at this. This is a double bond. And in this case, this is a double bond. So like which double bond is much more stable here? Like A is more stable or B is more stable. So in this case, if you're observing that this is a CO there, okay? And one more thing, this is COCH3. Wait. Just let me know that if you're having a carbon-carbon double bond, it is stabilized with electron withdrawing group and a carbon-carbon double bond or electron donating group. Yes, please answer this question. It's a very, very basic question. If there's a carbon-carbon double bond, so it is stabilized by the withdrawing group or the donating group. You know, in both the cases, the substitution is a Let's just back again what I want to highlight. That look at this in this case, not this slide, please. Okay. So in this case, if you're observing that is a carbon double bond, so this time we can't calculate like alpha hydrogen on that part. So simply, like according to you, A is more stable or B is more stable? Or like double bond is much more stable with the electron donating group or electron withdrawing group? Okay, so listen that if you're checking for the stability, okay, maybe wait. I hope it's not very clear. Let's suppose this is a OH and this is a COH. Okay, the point number one. And this is OH and this is a COCH3. Okay, so in this case, if you're observing, this group is going to stabilize more this. Okay, just try to understand what is happening. If this in this case this is a H positive ion, okay, you know the last mechanism, and this is H positive ion. So base come right, base come like base be like I have to abstract this hydrogen. So once it's abstract the hydrogen, there's a negative charge generated. Okay, again there's a negative charge generated. So which negative charge is much more stable? Now let me know, okay? Maybe that point will be clear for you. So which negative charge is much more stable here? Like negative charge A or the negative charge B? If sometime you're not able to understand directly, so go with the mechanism. Yes, please. A negative charge is much more stable or the B one? Or like which carb anion is more stable here? Come on. Now at least let me know. It's easy now. Okay then, so listen my point. That as we know, if you are having a negative charge, it is more stabilized with the electron withdrawing group. If there's a negative charge, it is inversely proportional to the electron donating group. So if you are observing the CUs are tie, okay, the CUs are tie, then what is the important part left? Hydrogen and CH3. So as compared to the aldehyde, ketone is being like a less electron deficient compound, okay, less electron deficient, and hence that the major product for the previous question is what? That option number A. That when both aldehyde combine. Okay, so this is how you can decide. First point, that is a you are checking electrophile or a nucleophile, then stability of a enolate there. Okay, hence option A is the major product in this cross aldol condensation. So do we have to remember every time the factor? No, okay, we are not going to remember. Okay, let's solve some question. Okay, like let's see which kind of question ask on this topic. Wait, I will give you a question. Okay, let's solve this question. It's a CH3CHO plus HCHO. Then I'm using diluted NaOH and heat. Okay, so you have to identify the product. Like what is the major product simply. Okay, so options are okay, technically this is not stable. Any the only one choice is there. Okay, just let me know the product. Okay, I will give you some option. A, B. Just let me know A is the major or the B is the major. Okay. Yes, please. Which one is the major product here? Yes, please. A is more major or the B is the major one? Okay. So listen my point, what I want to ask basically in this question. Okay, so you are having the point number one. It's a CH3. Okay, definitely it's not like we're just taking one mole, right? We can take any mole. So the condition number one, maybe the CH3. Wait. Okay, this is the first thing, and this is the second thing. Can you just tell me, like between A and B, which one I have to select as electrophile? You know the point number one, that is the formation of enolate ion, right? Enolate ion. So what is the condition number one? That OH come, OH going to attack. OH be like, I want an alpha hydrogen, I want more acidic hydrogen. So OH be like, do you want to give this you HCH will be like, no, I don't have any kind of alpha hydrogen, then how can give you? So in this case, there's a zero alpha hydrogen. So definitely it's not going to behaving like a normally nucleophile. So this condition number one omit, right? Then OH will be like, not an issue, I can go there because there's alpha hydrogen. So just by using this point only, that one point is very sorted that it's behaving like a electrophile. Okay, it's behaving like a, sorry, nucleophile there. So the point number one is clear, and then plus that HCH is there. Okay, so after deciding the first point, everyone, that how the step one is going on, like which one is being like and all it. Now the second thing, okay, this is the thing that which is going to react, that nucleophile simply. Right, this is the nucleophile, and this nucleophile is going to react. Now my question to you, this nucleophile has a choice, maybe it attack here or maybe it attack here. If you have to follow, that is the condition number A. Let's say this is a condition number A and this is a condition number B. So condition A, definitely you are end up with the option number A. Or condition number B, definitely we are end up with the option number B. So like which one is the most feasible attack here? You have to go with A or B. Of course, after the completion of the carboxylic acid. Okay. Yes, please. A or B. Which one is the feasible attack? Are you getting my point? A. Okay. Okay, cool then. So in this case, this is a nucleophile, okay? Everyone, okay? So this is a nucleophile. So nucleophile will like I'm searching for electrophile. So this is a partially negative, this is a partially positive, this is a partially negative, this is a partially positive. Between A and B, where this nucleophile is really going to attack. Because you know that this point is already a type point. Like if you were to observe CH is there, so the same CH is there. So now which one is a better electrophile? Yes, please. Previously, we discussed about between ketone and aldehyde. Aldehyde is a very good electrophile, right? Because a ketone has two CH3 group. But in this case, that both are the aldehyde. So which aldehyde is a better electrophile, or which aldehyde is electron deficient? Yes, please. A or B. Which one is a better electrophile? So answer is what? Option B, okay? So B is the better electrophile. Why? Because only hydrogen is connected. But here CH be like, I am a better electron donating group. So this carbon is not that much electron deficient. So this be like, no, I can't go there. Better to go with the that formaldehyde. So this is how it's going to attack and what we are end up then. So we are end up with like H double bond, and this is a CH. I take here OH and hydrogen. So this is the final product. And if you to go with the hydrolysis step as well, so this is going to leave. And okay, we are end up with the double bond, carbon double bond here. So option B is the correct answer here. Okay, is this question clear for everyone how to decide? Let's solve more questions. Okay, I know that aldol condensation is not very easy reaction. So let's solve more questions. One more question, okay? Okay, before that, let's discuss about the second one. Then at the end, we are going to discuss every question. Okay, so let's discuss the third type. We already covered the simple aldol condensation when we are having only one molecule, maybe aldehyde or maybe ketone. The cross aldol when we are having two different kind of aldehyde, or one aldehyde, one ketone, or two different ketone. Okay, now let's discuss about the third type, that is a retro aldol. So what is the meaning of this word retro? Retro be like opposite. So let me just write first of all retro-aldol condensation. It's a third type of aldol condensation. Retro-aldol condensation. Okay. So in the retro-aldol condensation, that same thing we are going to start that substrate. Like previously we discussed about like carbonyl with at least one alpha hydrogen. So in this case, be noted, that's just right in the bracket opposite of the aldol. Okay, I will tell you how it's opposite of the aldol. Substrate, first of all, I'm sorry, substrate we have to require, right? So how about the substrate? Substrate is going to be the beta hydroxy carbonyl compound. Okay, so beta hydroxycarbonyl compound in short, that do you know the aldol product which we just discussed? This is a CO and this is a COH. Wait, and this is a CH. Let's just write the hydrogen, and this is CH, and this is a COH. So this is the same thing that we are getting in aldol condensation. So it's beta hydroxy with respect to this carbon. This is alpha carbon, this is beta carbon. So beta OH group is present. So beta hydroxy carbonyl compound. It can be aldehyde or it can be ester as well. Okay. So how about the reagent? That for the reagent, then again we are going to use the NaOH. Any strong base, like as you know in the previous class we discussed about, you can use Na2CO3. Okay, or you can use barium hydroxide as well. But the most frequent, the most common is the NaOH is there. Okay, sometimes these two can be used. And the final product, what we are getting as a product, that aldehyde or a ketone. Like we are just doing opposite, aldehyde or ketone. So for example, how it is going to work, let's discuss by using a question. Okay, so let's see that if I'm having, it's a carbon, OH, it is a CH3, okay, CH3, and okay, this is a CH2, C double bond, and a CH3 there. Okay, so this is the product we are getting. How to go with the final step? That I'm using NaOH normally, okay, NaOH is there. So just search that OH carbon, just break them, okay. But where the OH connected, just break them, okay. So you are having this NaOH, simply fit the water there. It's like a hydrolysis. So you can say that in this case we are end up with this side, that is a CO, CH3, and a CH3. This side, okay, this side. And the second side, if you have to observe this part here, what we are getting, that this, what will be the carbon, it is connected with the CH3 and a CO and a CH3 there. Okay, did you notice something here, that observe this O simply move from there to there, that's it. It's become CH3 and it's become carbon double bond oxygen. Okay, this is how you can decide that what is the final answer here. Okay, let's solve one more question. Same trick here to apply and then find out the answer. Okay, this is a kind of question. So question, okay, we have to use OH. Yes, please. You have to identify the product for this reaction. Okay, that NaOH if I'm using. So what is the product? So options are, option number one, like two time, that is the same molecule we are end up. B. Then again, that is a two time, same molecule where end up. And the option number three, plus means one more product, okay? Yes, please. I guess this is easy reaction. Now let me know which was the correct answer here. Okay. Of course, Dashika, I will tell you. Till then, okay, please solve this, okay? After this, you're getting your answer. Dashika, just wait for some time. Yes, please. What is the final answer? A, okay, Shiva. Do you know you can solve this question just by counting the number of carbon? Okay, Shiva. And now try one more time. Of course, Shiva. That's it. This is the retroaldol. Okay. So whatever be the substrate we are starting and we to add NaOH. So the answer, okay, the final product. So it's be like that from where we're starting and then we are end up with this kind of product. So it's just like we are breaking the product of aldol again into the aldehyde and ketone. Okay. If you to go with a hit and trial method, like okay, let's select the option and try to solve. Okay, it will be very lengthy for you. Just apply the trick. Okay, if you're not getting, don't worry, I will repeat one more time. Okay, I hope it's not very clear, right? So look at this, that how to approach. So this is my OH. You have to just search for OH carbon and one more carbon. Just break this bond. Okay, just break the bond between the carbon, which one has OH, and the second one that the this, okay? Like this is the CO part. And if you're breaking this, let me just count the number of carbon. One carbon, two carbon, three carbon, four carbon. First point sorted. Okay, second side. If you observe the second side, this side, one carbon, two carbon, three carbon, four carbon, and five carbon. Did you notice something? That is this side you are having four carbon, this side you are having a five carbon. So definitely that if I'm going to go with the option number one, it's a one, two, three, and four. Only four carbon? It's not possible. That one, two, three, four, and five. Only five carbon is it is possible? No. So just by using this part, that I can simply omit that A and B is not going to be the correct answer, right? So let's see that you're asking how to apply the trick. So in this case, that if you're observing that if I'm breaking the bond, let me just break the bond. If you're to break the bond, okay, so this hydrogen simply transfer here. This is just a trick. Okay, this is not the mechanism. So then what we are getting that simply the double bond formation there like this, okay, and here that CH2 form. So if you're observing something, okay, what will be the final answer? That CO. Okay, this is correct, and 1, 2, and 3 carbon CO. So this is correct. Okay, so last option is the correct. And Dishika, let me know, is this point clear now that how to approach or still any problem? This is a retro aldol condensation. Yes, please. If still there is a problem, I guess got it, right? Please connect again if still the problem is there. So this is the third type, that is a retroaldol condensation. Okay then. Now let's discuss about more about the aldol condensation. Let's solve some more type of question. Although they are not being like aldol, but still how to approach the questions. Okay. So some question, try to understand the mechanism, same ditto, same mechanism, but yeah, answer can be different. For example, this is a question for you. I will tell you how to approach. So it's a CH3, simply and a CO, CH3 there. Okay. And in this case, we are using carbon triple bond and nitrogen and hydrogen. Okay, and in this case, I'm using dilute NaOH. Okay, so first of all, every time in organic chemistry, search for this dilute NaOH. If diluted NaOH is present there, so if let's suppose I don't know anything, okay, why not extra H? Why not extra H? Okay, no, 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 Dashika, listen, listen, listen. If back there, okay, let's just back. You're breaking the molecule simply. Okay, you're simply breaking the bond. So this OH bond, the hydrogen simply transfer there. So it's become CH2. Okay, see this. I have to highlight. This become CH2 there. So it means hydrogen transfer there, and this oxygen become double bond oxygen. Okay, this is just a trick. It's not like hydrogen is coming. No. Okay, Dashika. That in this case, simply that we are following the reverse of the previous one, that is the aldol condensation, Dishika. Okay, so that's why no extra hydrogen, nothing, that the molecule itself shuffle there, and then the transfer take place, and we end up with the reagent which we already start or used in the aldol condensation. Okay, Dashika, that's it. Okay, so let's see what we're discussing again. This question, please. So, yeah, what we're discussing that in this case, you know how to approach the organic chemistry question. I'm simply telling you this point here. Diluted NaOH. I know one thing, this is nothing, it's behaving like a base. So, base means OH is waiting. So, base be like, I want a hydrogen molecule. Hydrogen means proton. So, can you just tell me that there's a two molecule, that is a molecule number one and a molecule number B. So out of A and B, this is the point number one, this is the point number two. So which hydrogen is more acidic in nature? Yes, please. Anyone? Which hydrogen is more acidic in nature? Okay, maybe some problem, like mistake. Okay. Yes, please. Which hydrogen is more basic here? Sorry, sorry, sorry. Acidic. Let's say this is A. Okay, this is B. Like which is going to attack on first, which hydrogen? Again, the normal basic GOC concept. Okay, then so listen my point. That if you are going be like ma'am, negative charge generated, right? The point number one after the section of the hydrogen there. So okay, after this, what we are getting basically that in this case resonance. In this case resonance. So resonance, there is a type for the resonance. So resonance is not the important point. Now we are checking for the electron withdrawing group, right? So now between the CN group and this group, so which one is a better electron withdrawing group? Yes, please. The cyanide one or like this be like it's kind of aldehyde. Which one is a better electron withdrawing group? Now this is normal basic GOC question. Yes, please. Cyanide, right? After I know this, the CN is going to be the next strong electron donating group, withdrawing group. Okay, so this is a strong electron withdrawing group as compared to this one. So we can say better. A, B is more stable over there. After deciding all the things, let me just erase like what we are discussing. So then that negative charge is ready, right? So negative charge is ready, and this is again CH3 there. So after this, obviously, like the previous one, enolate ion did to the aldol condensation kind of mechanism. So this negative charge simply move here, this double bond move there. So we are getting it's a carbon double bond, and let's just write be like this just for convenience only. Okay, like this. And just because of the nitrogen has a less bond, there's a O negative charge generated. Okay, so like mechanism wise again the same, that this O like negative charge transfer here and this simply attack here and this bond open up. That's why in organic chemistry mechanism part is important so that we can handle any type of reaction. Okay, so we are getting CH3 and this bond open up O negative, and this is a CH3. So what will be this? It's a CH2 and this carbon triple bond nitrogen simply there. Okay, again, what is the step number two? Same the protonation. You know the water hydrolysis we are using. So again, this O negative attack here, and we are getting it's a CH3 and a OH. Okay, CH2 carbon triple bond nitrogen, and it's a CH3 there. So this is the final product for this question. Okay, this is how you can find the question or like the final answer here. Okay, now let's see one more question. Okay, for this one you will tell me. Okay, last type, same type, aldol type you can solve. uh, so this is a benzaldehyde. For this one I'm going to give you some options as well. It is a CH3 and NO2. Think about it and then let me know the answer for this one, like 1.5 minute, like 1.5 minute, and then okay, answer the question. So what is the final answer? Option number one. Okay, option number B. Option C. Yes, please. Which of the following is the correct answer here? Okay, take your time and answer the question. Yes. Which of the following is the correct answer here? Okay, again, take your time. Try to answer the question. Maybe we are end up with the final answer correctly. Okay, let's suppose this question is in my exam. So, like CH2 group is a minus M group. So it's a ortho para and meta and like which directing type? And then I have to go with the option number A. How about you? Anyone? Are you getting the correct answer? Okay, Shivam. Okay, so let's see the correct answer for the question. So I know like what you are going to do. It's a minus M group, right? So it's a meta directing group. So and hence option E is the correct here. Okay, option A is the correct here. But just try to understand the scenario. Like, if you to go with like option A is the correct, so it means that this benzene is going to attack on some kind of electrophile. Recall the electrophilic substitution reaction, right? But if I'm observing some kind of OH, so OH is definitely going to abstract the hydrogen and definitely the negative charge generated. Positive charge never ever going to be the generated thing here. So A and C out. No, it's not okay. So what is the answer then? So in this case, I'm searching for one point that again, this is my benzaldehyde. Okay, this is my benzaldehyde and it is a CH3 and NO2 group. And this is a OH negative ion. It's a base. So base is going to upset the what? That is hydrogen. So base be like hydrogen, come on, it's not acidic hydrogen. The direct connection of the hydrogen with the Cu group and you're going to abstract. No, it's not stable. Now we're left with only one choice that is NO2, that electron withdrawing group, the strongest electron withdrawing group. So definitely the OH group is going to obstruct the sides in there. Okay, so it's become CO negative. So the thing that is going to attack now the CH2 and NO there. Okay, so like every possibility there. This is O negative, and like if you to go how it's look like, it's a CH2 double bond. Like let me just write how. Okay, let me just write the NO2, how it's look like. This is NO and a double bond and O negative. This is a positive charge, right? So in this case, this O negative simply attack here and this bond up and up. So it's like enolate kind of thing from again. It's a CH2 carbon double bond and okay, nitrogen double bond. Okay, and this is O negative, this is O negative, this is a positively charged. Then the next step, same aldol kind of thing. That double bond simply attack here. Okay, wait, let me just take this here. So in this case, aldehyde, it's going to attack. So double bond attack here, this bond open up. So what we are getting finally, it's a CO negative and a hydrogen. And this is a CH, okay, and nitrogen. Again, double bond and O negative positive charge. Okay, the next step is what? Again, the protonation that OH connected here. So this is the final answer for the question. Okay, so let's just back again. Okay, look at this. The option B is the correct answer here. Option D, then how the OH is there? It's not possible. Again, option B is the correct. Okay, so any issue with the question, please let me know. I hope the question is clear for you, but still any problem? No, again, Shiva, D is not the final answer. This is the final answer. Okay, the OH. Be noted what is the main agenda, that which one is being like electrophile. Definitely the OH is going to connect with dead carbon. So it's fixed. The OH position is fixed. It can't be changed. Okay. So I hope this question is clear for you. Let's see the last type of aldol condensation. That is intramolecular aldol condensation. So it's very much frequent or the common one. Intramolecular aldol condensation. The last type of aldol condensation. Okay, cool. So what is intramolecular aldol condensation? We discussed so many times that inside, the meaning of this word sorry, intra. I'm really very sorry. It's not inter, intramolecular. So what is the meaning of intramolecular? That is inside the molecule. That if you are having a molecule and inside the molecule reaction is going to take place, so it's become intramolecular. So for example, how? Let's say, okay, this is a CH and a carbon double bond and it's a CH2. It's a CH2 and a CO, and let's suppose this is a CH3. Okay, so what is the thing which we are doing right now for aldol? We are having one is being like electrophile, one is being like a nucleophile. Okay, so two different carbonyl. Like basically two thing is going to connect. But in now in the same molecule we are getting this and this two thing. Okay, so let me just tell you like actually how about the aldol condensation. Everything we're going to discuss. Don't worry. So again, if let's suppose I'm using a base, base is going to abstract, let's say this hydrogen. So O negative generated simply here. Okay, this bond like this. So this O negative simply attack here. Okay, so like in the same molecule thing is going to happen, and this bond open up. Okay, and every time when you are solving these kind of question, better to give numbering. So it's a one carbon, two carbon, three carbon, four carbon, and a five carbon. It means that we are end up with a five member ring there. Okay, so let me just write the number. It's a one carbon, two carbon, three carbon, four carbon, and a five carbon. So let's see what is connected here. So on the fourth number of carbon, if you're observing, this is my four carbon. So there's a carbon double bond. Okay, sorted. Now let's look at the carbon number one. For the carbon number one, okay, O group connected, and this is how it's look like. O negative. Why? Because this bond open up. So this is how it's look like. Okay, the point number one. And next, it's going to convert into the OH ion. Okay, so this is the final thing we are getting. What is it? It's intramolecule, inside the molecule. So at the end, we are at end up with a ring formation there. Okay, so it means now in the intramolecular aldol condensation, no, it's not Perkins. Okay, Perkin and these reaction we're going to discuss in the next class. Okay, for this one only aldol. So it's a kind of ring formation in short. Okay, so now it means in this case we are going to check it for the stability of the ring. Okay, it's not like every time okay we are end with some product and we're going to approach that. No, so stability play a very much important role. So if we are discussing about the ring size, so like how about the ring size stability? You know, six member is much more stable with the four member is much more stable with the four, five, four, and three there. Okay, but if you know the basic thing that in this case really the three member ring is much more stable over the four member. So this is the correct stability order. Six, then five, then four, and then three. Okay, but better three is more stable over the four there. Okay, so in books, may most of the time three and four, but really the order is going to be the three and four. This is the final order. Okay, don't worry, we're not going to check it for the three and four member. The only six and five is the topic of discussion right now. Okay, so let's discuss every scenario, like how I'm saying that 6, 5, and 3 and 4. Okay, let's see an example. Let's suppose this is my CH3. Okay, this is a CO. It is a CH2, CH2, and CH2, and CH2 and CH3. Okay, so this is the thing I'm getting. Okay, this is a kind of question. So now in the point number one, let's consider every possibility. Okay, so in this case, I'm using first of all base. Base be like my motto is what I want proton. Okay, so like every proton, let me just highlight this proton, this proton, this proton, or this proton. Sorry, not this. That is this proton. So every proton is acidic. The proton which is connected next to the Cu group is the acidic one. You know, once it's generated O negative, it's stabilized, O negative stabilized, O negative stabilized, and O negative stabilized there. But now my point is what? Like out of all the cases, let's just see that this is A, or this is B, or this is C, or this is D. So from where I have to stick the hydrogen? Like the A, like B, like C, or like D. Okay, so the condition number one. Condition number one, let's suppose I am considering the point number A that I am taking the normally hydrogen from the carbon number one. Okay, and then you have to just count the number only, and then that's it, you are getting your answer. For example, this is I'm taking, so count one carbon, two carbon, three carbon, four carbon, five carbon, and six carbon. It means I have to start with the carbon number one or the carbon number A. So we are getting a six member ring. Cool, so it can be feasible. So means according to my counting, A is better. A is better. right? So just by using this, just remove this, that for the A, we are getting six member ring. This is how you have to decide. Okay, so let me just erase now. Now, let's discuss about the point number B. Okay, so if I'm taking the point number B or the hydrogen number B, okay, hydrogen number B there. Again, let's start. That is the carbon number 1, carbon number 2, carbon number 3, and carbon number 4. Come on, 4 member is not stable. So I have to rate that if I'm starting with B, so we are end up with a 4 member ring. So it's not technically feasible. Okay, so what of the third point, that if I'm having the carbon number 3 there? Okay, some of you will be like, ma'am, if you're taking this, then why not attack it? No, 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 no. That it's one carbonyl and it's going to take the second carbonyl. Same if you to go with the C. How about the numbering there? Let's just count. Okay, so it's a carbon number 1, carbon number 2, carbon number 3, and carbon number 4. Again, it's a 4 member ring. So for the C carbon, again it's a 4 member ring. It means this is not stable. Okay, so I'm going to erase this now. Okay, let's erase this now. D, okay, that the D part. So for the D part, this is my D. Okay, so for the D, let's count the num again. 1, 2, 3, 4, 5, and 6. Okay, cool. Then that is for the D. We are end up with a six member ring. So just by using this, I am now observing that you can go with A or you can go with D. Both can be feasible, but B and C is not possible. So let me just erase this and this. Okay, this is how you to select simply that the ring size. Okay, so now let's see again. I'm erasing this. Okay, after all the discussion, B and C out. Okay, now if you to start with this carbon, okay, this carbon, the point number 1. If you to start with this carbon, which kind of enolate we are end up? This kind of enolate, right? And if I have to go with the option D, like the last one, so in this case, this kind of enolate we are getting. So basically, I'm doing nothing, that we are just directly checking for the stability. First, you have to decide the carbon number, like the chain. And the second point, that between A and D, according to you, which enolate is much more stable. This is how you to decide that A is more feasible or D is more feasible. Yes, please. D is more stable enolate or A is more stable enolate. Remember, I only told you how to check it. That in this case, this is the point of discussion. This is a point of discussion. And how many alpha hydrogen in this case? If you have to observe, that is a 2 alpha hydrogen this side. And in this case, there's a 3 and 2, total 5 alpha hydrogen. So which double bond or which enolate is more substituted or stable? That is the D there. Right? So D is much more stable. Okay, so this is how I decide that is the D is the feasible answer there. Okay, after this, let's back again what we want. Okay, erase this complete thing. So this is my stable enolate I'm getting now. Okay, and don't do these kind of thing again and again. Once just generate the negative charge and that's all. So it's a double bond and double bond and negative charge. Let's simply attack this attack here. Okay, so again, write the number 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, and 6 carbon. So it's going to be a 6 member ring. Okay, so let's see the number. So I have to start 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, and 6 carbon. So 6 carbon, okay, this is the sixth carbon. The CH3 group is connected on a sixth carbon. This. Okay, and then at the first carbon, that O bond open up, and on the first carbon the CH3 group is also connected here. Okay, and this is how you can decide by numbering the thing which we are getting right now. Okay, once you are getting this, next step is what? Protonation again. So what about the next step? That it is OH CH3 group connected. Wait, where's the Cu? 5 carbon. Okay, double point, I'm sorry I missed this. The Cu group have to be there. Okay, so Cu CH3. Okay, that's it. Now, again, if I have to go with the hydrolysis step here, so what is the final answer? It is a CH3, double bond CH, and a double bond. So this is how you have to decide the product in a aldol condensation. Okay? Yes, first of all, anyone approach is not clear, let me know how to decide. Okay, don't worry, we're going to solve some question. But first of all, is the approach part is clear? Like A is the correct answer, B is the correct answer, or like how to decide? Yes, please. Okay, if you're not responding, so I'm assuming that it's okay, right? So let's solve a question. Last question. After this, the Aldol part is going to be the complete. Okay. So let's see a question. Okay. Okay, yes, please answer this question. It's a CH3. Okay. This is the product, and I'm using which you have to identify the final answer. Okay. So there's a options for you. Just let me know the answer. Okay, this is the option number one. And one more thing, like six is more stable, the five is more stable, the seven member. Okay, I missed the seven member. Yes, please, which of the following is the correct answer here? Okay, A, B, C. Okay, let's see the none of these. Yes, please, which of the following is the correct answer here? Take your time and please, it's a request, everyone answer the question. Last question of the class, please answer. Yes, please, what is the answer for this question? Okay, so let's solve. So in this case again, like which means is the L, the acidic this hydrogen, or this hydrogen. These are the acidic one. So again, count the number of carbon. If I'm starting from this one carbon, two carbon, three carbon, four carbon, and a five carbon, so it can be work. Okay, let me just mark it that it can be the correct maybe. Okay. Next point, that if I'm starting from this. Okay, look at this one carbon, two carbon, three carbon, four carbon, five carbon, six carbon, and seven carbon. And even you can directly omit the option number one. Seven is not feasible answer here, right? Seven is not the feasible answer here. So let me just erase this. Not simple, sorted. Okay, now how about so this is out now. It's wrong. Now look at this. If I'm selecting this hydrogen, okay? So with respect to this one carbon, two carbon, three carbon, four carbon, and a five carbon, like, so do you have to go with the purple one or a red one? Which one is the correct here? Okay, the only one thing that this is how you can go, that just simply check it for the normally double bond stability there. Okay, so again, let's see that both the point. If I'm taking this one, okay, so let me just first consider this here. So it's a C double bond O and a negative charge generated. Okay, so it means that if you have to go with the enolate formation there, so this kind of enolate we are getting, O negative and double bond. This kind of enolate we are getting. And the point number two, okay, that if you have to go with this, okay, this, I have to write on the top, okay, so it's not visible, okay, here. So it's a CH3 and a carbon double bond O. Yes, O negative here. Yes, please. According to you, uh, which double bond or which enolate is more substituted? I'm sorry, I missed the oxygen here. Yes, please. Which enolate is more stable? First point, the number of ring. Second point, enolate is there. So, like, which enolate is much more stable? Okay, so let's see that with respect to this 1 and 2, right? So, total in this case 1, 2, and 3, 1 and 2, total 5 alpha hydrogen. Then, how about the this case? In this case, if you're observing this only, and 1 and 2, so it's a 2 carbon, 2 alpha hydrogen. So definitely this is much more stable on this. So just by using this point only, that I am able to observe that this is going to be the stable one. Okay, this is going to be the stable one. Okay, so then I'm going to raise this, and then this double bond simply attack here, this bond open up, hydrogen, and we are end up, this is the final answer, CO and a COCH3. Okay, this is the final answer. This is the point number one. This is how you can decide. Or even you can decide, do you know that look at this, it's a aldehyde and this is a ketone. We already covered this point earlier that if I'm having aldehyde and ketone, so aldehyde is a better electrophile. So definitely this is going to attack on aldehyde. So yes, the correct answer for the question is only option number B there. Okay, not C. No, C is not the correct one. Okay, so like how to go with the enolate step. The point number one, ring. The point number two, aldehyde or ketone. If ketone is there or aldehyde is there, every time aldehyde is going to convert to the OH1. Okay, point number three, if there's a type both are the ketone, then you can go with the more substituted enolate ion. Okay, and hence that's why in this case option B is the correct answer here. Okay, so any problem, this is all for the aldehyde condensation, this is all for the class. Now your turn, any doubt, any problem, please let me know. And aldehyde condensation is really important, like I guess 2 hour class just for aldol only. And next one we are going to discuss about some Claisen rearrangement and Perkins one, and there's so many reactions still there. Okay, so next 2 to 3 session is going to be the important part. That's it. Now your turn, please. Any doubt? Okay, Jatin. So thank you so much then everyone for joining the class and have a nice day. Thank you so much. Thank you then.